Your eyes are not playing tricks on you. I am going back to our original sheet. It's all marked up, I know, but what I like to do is spend a little bit of time talking about what we call domain and what we call range. We're going to talk more about this in section 7.2. I'm stuck on the other class I'm teaching. But 7.2, we'll talk more about this, but we'll get a feel for it in this chapter, and I do believe there's some homework problems to deal with and to talk about. But what the domain is, we already have the idea that a relation or a function is an input-output system. So your domain is basically a set, keyword on set, right, of inputs that create an output. So whatever I can put into the function and make the function work is going to be in the domain. So really look at the action there. So it's a lot of people mistake it as being all the x values. And yeah, that's where it starts as, but it has to actually create an output. So if you have an x value that doesn't create an output, it's not in the domain. It's something that I put in that creates something to happen. All right, so a range, what the range is, we usually call it y, but it's not just y. It's another set of outputs that are actually created by the rule. So if an input and the rule does not create that y value, it is not in the range. So there's this action going on. Everything is all about action. I'm putting something in, it's actually making the function work, and we're getting something out. So that's what the domain or the sets that make the function work and create an output. The range is the set of things that came out that were actually created. So for example, let's go talk about the domain and range of each one of these. So the GCC rule, well, we just said students. But we know, right, that there's some rules, if you would, or there's some restrictions on the student, right? My grandson right now probably would not make the GCC rule work. So even though I can put him in here, I can bring him into a classroom, have him sit down, he can sit here and watch the videos, but he's actually not going to make anything work. He's not going to actually create a situation where he can get transfer credits or certification or an AA degree. So a student, right, usually you have to have a high school or an equivalent diploma, a GED. Some of you are dual enrollment, right? So I don't know if there's really an age requirement, but you at least have to have this in your little toolbox of things that you've accomplished before you come to GCC. There's a placement test you have to take, right? So there's a lot of little restrictions that we put on a student before we actually put them and enroll them at GCC, right? You have to pay your tuition, right? There's tuition dollars that come in. So very complicated domain here. So not only, it's just not anybody. I would describe the domain as somebody who has the money, right? On a high school equivalent, or they're a dual enrollment student, or they've passed the proper placement exam. If we have that type of student, we can put them into the GCC relation and actually create some sort of an output. What is the output? Well, you're kind of looking at it here, right? So this would be your domain over here, sorry. And this would be your range. And of course, we can probably even add to this, right? You know, a lot of you guys are here for different reasons. Maybe you learned ASL, right? So that would be one of the range values. But for sure, many of you here for transfer credits. Some of you do get a certification. Some of you get an AA or maybe even an AAS. All right, so the range, anything that is possible, anything that a student can accomplish here at GC would be in the range. Gumball machine. When we left this, it's not a function, right? It's a relation, but we said we can put anything into the gumball machine, and that's not necessarily true. Sometimes it only takes 5 cents, right? Sometimes it takes 10 cents. A lot of times it takes 25 cents. Sometimes, if you're at Peter Piper, it only takes a token. So again, depending on the gumball machine, to get it to work, we have to put in the proper input. All right, how about we just say it's a token, a Peter Piper token. So there would be our domain for our gumball machine. If I put in a nickel, the gumball machine, you can sit there and press on the dial, but nothing's going to work because it doesn't accept 5 cents. It only takes a token. All right. Once I put the token in, what comes out is the range. And let's take the toy out of there, but it's a gumball. So maybe it's blue, maybe it's red, maybe it's white, maybe it's yellow, right? And so the range might be all the different color gumballs that are possible from that gumball machine. Alrighty, so domain, my set of inputs. and my range, my set of outputs. What makes the rule work? For my hourly rate here, I either work or I don't work. So the set here, it's actually going to be an interval, right, starting at 0 and probably going out to 40, right? So any time value between 0 and 40. And I'll explain more what I'm doing here, but hopefully just my language, it makes sense. So if I work anywhere between 0 and 40 hours, all right, I can put myself into this function and create some sort of an output. So we're restricted. Maybe your company allows you to work past 40 hours, so maybe your domain changes a little bit. But normally, right, anywhere between 0 and 40 hours is a full work week. So I put in anywhere between 0 and 40, it's going to make this function work, and then what pops out is money. Now, if I work 0 hours, I'm going to get 0 money back. If I work 40 hours, right, we get $480. So the range would be anything between 0 and 480, because at the minimum we'll make $0. I didn't work at all throughout the week. If I put in a 40-hour work week, right, times 12, I believe that's 480. Alrighty. So again, what comes in, what comes out. So a negative value is not going to work here. Even though I can say 12 times negative 2 is negative 24, I can do it, but that doesn't make sense for this rule. So again, the set of inputs that actually create a valid output, that's what's in your domain. Here, the domain, well, there's only 5 values. There's a lot of other x values that we're aware of, but as far as this table is concerned, it's only showing me 5 pieces of input. I only know where 5 inputs create some sort of an output. So negative 2, negative 1, 0, 1, and 2. And what you're looking at is the difference between what we call a discrete set and a interval set. Most of the things we're going to work with in this section are going to be discrete. So we're going to list every single value that's in the domain. Here, it's hard to list every single value because there's halves and 3 halves and 2.6, 11.75, right? So we're talking literally everybody between 0 and 40. Here, when I use discrete notation, I'm just talking distinctly about the number negative 2, negative 1, 0, 1, 2. No fractions allowed or nobody in between. What about the range here? Keep forgetting, that's the domain. What about the range? Well, what are my outputs? All right, what are all the pieces of output that came out? Well, it looks like 5, 8, 9, 10, and 11. So again, this is another discrete set. We're not talking about everybody between 5 and 11. We're only talking about 5, 8, 9, 10, and 11. All right, a little bit harder, and this is definitely taking us into 7.2. So if you can follow, good. If you don't panic. I'll explain more. But this function, I note the arrows here. So along the x-axis, this action goes on for forever. So the domain is everything. I can put any value of x I want into this function and eventually create some y value. The range is fixed. It looks like it bottoms out right about here. How about we say that's about 1, and then it goes forever to positive infinity. So the range would be from 1 to infinity. So again, what inputs can I put in here? Anything I want. What things come out? Well, anything above 1. So that action, your domain and range depend very heavily on what rules given. And the domain is what's the set of inputs that use the rule and actually create a piece of output. So let's practice that a little bit more in the next video.